In this video, I will discuss Matlab code of LU decomposition using Crout method. LU decomposition is basically used to solve system of linear equation in linear algebra. And there is another method for LU decomposition that is called do-little method. So Crout method and do-little method, they are slightly different from each other in a way that formation of lower triangular matrix L and upper triangular matrix U is different. Whereas the steps of solution, or we can say that the method of solution is exactly same. So firstly in the question you are given with some system of linear equation. And first thing to do is to write it in the form of matrix, that is Ax equals to B. So after writing in this form, how can we solve it? First thing is to suppose that A is equals to Lu, and we will replace A by Lu in equation and we get Lux equals to B. After that, we have to suppose Ux equals to Y and the equation become Ly equals to B. Now we have basically here three equations that we have to use. A equals to Lu. Using this equation we will find the matrix L and matrix U. After that, using the equation Ly equals to B, which can be written as Y equals to L inverse of B, we will find the matrix Y. And then using the equation Ux equals to Y, we will find the elements of X, that is by writing it in the form X equals to U inverse Y. And that will be the solution of the given system of linear equation. So now check the formation of lower triangular matrix and the upper triangular matrix. The matrix L is the lower triangular matrix and the matrix U is the unit upper triangular matrix. Its diagonal entries are 1. This is the difference between the do-little and Crout method, that in Crout method the diagonal entries of U is 1 and in do-little method the diagonal entries of lower triangular matrix is 1. So now we have to check what are the inputs that we have to take from the user. That will be the size of the matrix A and matrix B. These are the inputs that we have to take from the user. Now first thing is to take the size of the matrix as input. I am representing it by the variable n, and using the statement input we will write here enter the size of matrix. So user will input a number and that will be stored in n. Now next thing is to input the matrix A. So I will write here nested for loop. If your array is two-dimensional, you will use the nested for loop. If your array is one-dimensional, you will use the single loop. So I equals to 1 to n. The next loop for j 1 to n equals to input, and now write here some message like enter a value semicolon, this end for inner loop and this is the end for outer loop. Now we have to take B matrix as input and we will again write a for loop, but before that we must tell that we are going to take input for the matrix B. So we will write here matrix B semicolon. So now a for loop to check the input for B, and we will write here 1 to n, and we will write here matrix B, A first subscript and 1 is the second subscript because there is only one column there, and we will write here input a message that enter a value and n for B. Now for X and Y matrices, and we will initialize both of them with zeros. So a built-in function zeros, and here we will write the size of the matrix. The next one is Y equals to zeros, and then here the size of the matrix. Okay, done with this. Now the next step is to find L and U. We know that in Crout method the lower triangular matrix first column is exactly same as the first column of matrix A. So it's better to initialize L with A matrix. And next thing, U. So we will initialize this with zeros, and this will be an into n matrix because it will be the square matrix. Now the next thing, okay, we will be done with the first column of L, and in the U matrix the first column, the first entry will be 1 and the remaining 2 will be 0. So there is no need to find any value for the first column or to work on the first column of L or U matrix. So we will take a temporary variable and we are naming it flag, and we will initialize it by 2 because we are actually starting our working from the column 2. Now we have to start a nested loop to find all the elements of the matrix L and U. So let's take B as the looping variable and we will write here 1 to n because the outer loop will run for 1 to n. Okay, now the inner one. In the inner one we have to start for 2 because first column, we are leaving the first column and we are starting it by 2. So let's suppose I am taking it as A, and the first value will be the value of flag because it is 2, and we will go for n. Okay, now the next thing, again we are taking a temporary variable holder, and we are writing here L, then B, comma, and the column will be A, and we always divide these entries by L of diagonal entries, and the diagonal entry will be B, comma, B. You close it, semicolon. So this is a holder holding a value. This value actually belongs to U. Okay, now another loop. So we need this loop to find all the possible values of L. So let's name it C, and it starts from 1 to n. So here actually we have to write a formula for finding the values of this one. Okay, the first one is C because we are actually taking it as row and A as column, equals to, we are writing here CA because recursively it will use its own values, minus, then we will subtract the value of holder, that we have found in the line number 18, and this value is actually multiplied by LCB. When you will dry run this whole formula and this whole program, then you will be able to check that how is it actually work. Now what we have to do, simply we will assign this value of holder to U, and what will be the subscript of U. So this is the row and this is the column. So we will write like this, and here we will write holder. You can also write this line number 22 after line number 18. It will not affect your program. So this end is for inner loop, and after this we need to have an increment in flag equals to flag plus 1. So why are we writing actually this increment? Because when next time the loop will be started, it will start from 3 and ends on 3 for a 3 into 3 matrix. Means it will run only for one time, the loop from that starts from 17. So now we will write end here. Now after that we need to do only one more thing. As we know that in Crout's method the diagonal entries of U is 1. So we will write here for I equals to 1 to n, and the entries at U I comma I means the diagonal entries. It will initialize them with 1, and this is the end for this loop. We are done with it. Now after this we will display U and L matrix, and the next step is to find the entries of Y. So we will write Y equals to inverse of L. Simply we are writing the formula that we use in the solution of the system of linear equation using LU decomposition. And in this way, using the formula at 31 line, we will find the entries of Y, and then we have to find the entries of X, and we are writing inverse of U multiplied by Y. So this was the whole Matlab code, LU decomposition using Crout method. Now we will run it and we will check our result. Enter the size of the matrix. So I'm entering here 3, then enter a value. Now we have to enter here the matrix. So 9, then I have -2, then I have 1, the next is 1, then 5, then -3, then -2, then 2, then 7, and now matrix P. Matrix P, enter a value. The first one is 50, then I have 18, then I have. So here is the result. Firstly, we have the matrix U with diagonal entries 1. It is a unit double triangular matrix. Then we have the low triangular matrix L, and then the next 3 elements of matrix Y, and then at the last we have the values of X, that is the matrix X. This is the solution of given system of linear equation.